Everyone, welcome to Math 60. Today we are covering section 3.1, which is called the Cartesian coordinate system, after a mathematician and philosopher named Descartes, spelled C-A-R-T-E-S. The Cartesian coordinate system, also sometimes called rectangular coordinates. And I'm using graph paper, which is great because graph paper's already got me most of the way there. If we were to represent a relationship between two variables, let's say x and y, well, two variables means that a two-dimensional picture would be pretty useful. Paper is two-dimensional, so let's use our paper. We're going to draw our two dimensions as a vertical dimension and a horizontal dimension. And where they meet is right in the center. So if you imagine looking at a map, and this way is north, and this way is south, and then you have east and west, you could find any point on the map by finding its coordinates in terms of how far east and how far north, or maybe how far west and how far south. So this point right here is, let's see, 1, 2, 3, 3 steps east, and 1, 2, 2 steps north. So if I had to get to this point, someone could tell me to take 3 steps east, 1, 2, 3, and 2 steps north, and that would get me right here. Now we have a slightly shorter notation. We're looking at a relationship between x and y. So let's consider x to be our east-west axis. X is east-west, and y is north-south. Then instead of saying 3 steps east, I would be taking 3 steps in the x direction. X is 3. And instead of saying 2 steps north, I would be saying take 2 steps in the y direction, y equals 2. So this point is the point where x equals 3 and y equals 2. I'm going to take a lot of pictures, so I'm going to go through paper pretty fast. Let me do another example, and as I do the example, I'm going to introduce a little more notation. The x equals 3, y equals 2 notation, that's super useful. I like it. I recommend using that notation as you're learning this coordinate system. However, as you get more comfortable, you're going to start using what are called coordinate pairs or ordered pairs. So instead of writing west and east, I'm just going to indicate this is my x-axis, which represents east-west. Instead of north and south, I'm going to indicate that that's my y direction, north-south. So here's my point where x equals 3 and y equals 2. And I'm going to describe that point with what is called an ordered pair. Instead of writing that x equals 3 and y equals 2, I'm going to write x comma y inside parentheses equals 3 comma 2. And when I see this list of symbols, x comma y equals 3 comma 2, that tells me that the x is 3 and the y is 2. Let's look at this point right here. To get to that point on my map, I don't go east anymore, I go west. I go 1, 2, 3, 4 steps west. Well, to keep track that I'm moving west, instead of using the word west, I just use the negative symbol. So this point is -4 on the x-axis because I took 4 steps, but I took them to the left. And then I still go 3 steps up, so I'm at a height of 3. So this coordinate point has a coordinates x equals -4, y equals +3. And if I were to write it as a coordinate point, I'd say -4, 3. I'm working my way in these throughout on the different parts of this coordinate plane. I was up in the upper right, and then I came over to the upper left. Let's do one here. That has the point x is -1 and y goes down 3. And so instead of saying down, we just make it a negative. Y is -3. And finally, over here on the right, x took 1, 2, 3, 4 steps to the right, and y took 1, 2 steps down, so we say it's a -2. And this coordinate plane allows us to plot any pair of x and y's. I mean, on this picture, I wouldn't be able to do like 10, 20, let alone 1,638,000. But you can imagine the axes extending out forever. And so that point does live somewhere. I could plot the point x equals 1,000,000, y equals 673,000 somewhere on this coordinate plane if my paper was big enough. This point right there is called the origin. And the xy coordinates are 0, 0. X goes 0 steps, y goes 0 steps. We haven't moved anywhere. We're where we started, so we're at the origin. All right, let's give these different parts of my coordinate plane names. We often put arrows on the end of our axes to indicate they go forever, but I don't really care so much. Sometimes I do, sometimes I don't. So we have our origin right here. We call the horizontal line, we call it the x-axis. And anytime you're on the x-axis, your y-coordinate will equal 0. Y always equals 0 on the x-axis. That's a little counterintuitive. Y is 0 on the x-axis. But if I draw a point, I've taken 4 steps to the right, and I haven't gone up or down at all, so my y-coordinate is 0. The vertical axis we call the y-axis, and x always equals 0 on the y-axis. Here's a point. The y value is -2, but I haven't gone anywhere left or right, so the x value is 0. All right, I'm going to squeeze some more into this picture. This whole part of the plane, all of this part is called quadrant 1, and actually usually use the Greek letter capital or the Roman numeral capital I. Quadrant 1 is the upper right. The upper left is quadrant 2 with the the Roman numeral 2. The lower left is quadrant 3 or 3 I's. And the lower right is quadrant 4, which in Greek numerals is IV. But if you want to just use Roman numerals, it's IV. But if you just want to use our Arabic numerals, the number 4, that's fine too. So this is our map. We've got the origin, the x-axis, the y-axis, and then we have the four different parts, quadrant 1, 2, 3, and 4. And that helps us orient ourselves when we're trying to plot points, when we're trying to show an XY coordinate pair. The main skill with Cartesian planes or Cartesian coordinate systems, at least as we begin learning them, is the ability to go between numbers and pictures and vice versa. So for example, here's my coordinate plane, XY. And if I need to plot the point XY equals -5, it's gonna work. I don't want -5, I'm running out of room. How about -3, 2? All right, so there's a numerical representation that x equals -3 and the y equals 2. And so I want to be able to plot that on my graph. XY equals -3, 2. That's moving from numbers to the pictures, and I want to be able to move back. So if someone says, here's a point right there, what's the x coordinate and the y coordinate of that point? I want to be able to say, okay, it was 5 steps right, so x is 5, and it was 1 step down, so y is -1. And if you can do that, if you can consistently plot points when they're given to you as numbers or identify coordinates when you see them on the graph, then you've learned everything you need to know about the basic usage of the Cartesian coordinate system. This is mentioned in the textbook, but I want to say it again. Always write XY equals before the coordinate point. Maybe not on your graph every time because it's pretty much implied, but maybe you should actually, at least for now, because intervals can look like coordinate points. Now, we talked about intervals earlier, like x is in the interval -5, 1. Well, that sentence means that -5 is less than equal to x, which is less than 1. This is all about x's. If x is in the interval -5, 1, that's a bunch of x values, everything between -5 and 1, not including the endpoints. And compare that to that coordinate point I just asked you about, x, 5, sorry, x, y equals -5, 1. Those look the same. And so if you leave these two parts off, the xy equals and the -5, 1, I don't know, am I talking about that interval or am I talking about that coordinate point? So especially as you're learning, it's really important that you label your intervals, x is in the interval, or maybe y is in the interval, and that you label your coordinate points x, y equals. When we talk about other concepts that have to do with intervals using a graph, it can be very confusing. Wait, am I talking about an interval on the x-axis or am I talking about a particular point on the graph? So please write x is in the interval, or at least the interval -5 to 1, or at least interval, something that clues you that this is a range of numbers all having to do with x. And please always write x, y equals -5, 1. All right, that wraps up this video. See you for the next one.